In this review, we start from the very beginning. We go back to the beginning of the semester. We talked about rates of change, and this was a sort of a preamble, preliminary discussion of sorts before we actually introduced the concept of limit. We needed to combine both things in order to define rigorously the derivative, which is what we've been doing lately. Geometrically speaking, we also saw there was a connection between rates of change or average rates of change with the slope of secant lines to the graph of a function. And when applying the limit, we will be able to get the slope of the tangent line. At least that's the intuitive notion, or this is what we expect to get from this limiting procedure when combined with the notion of limit. So we discussed, we had average rates of change. Here, there's really not much that we can say. The concept, at least when in regards to what is going to be expected of you on Thursday. So you're given a function f of x, and it's given by a certain formula. It may be a function of t. It's all the same. Suppose you're given the function, say, x cubed minus 2x plus 4, and suppose that you're asked to find so this is going to be problem 1 for now. Find the average rate of change of f. So of this function over a given interval. So over you can what's happening between 1 and say 3. So this is a kind of problem that will just basically be testing whether you remember the beginning of the material covered at the beginning of the course. This is not really anything involved, and it just amounts to evaluating functions, subtracting things, and computing a quotient. So remember that the average rate of change, change is just a measure of how quickly a function changes over an interval on average. Okay, so that's defined as a total change in f due to a change in the variable. In this case, not in this case, but in general, if they're asking you a problem of rate of change involving a particle, then you're usually measuring the rate of change according to time, or what's the same, the average velocity. Okay, so this is the average rate of change. So what we're measuring here is the change of f on the interval 1, 3 divided by the change in x in 1, 3. So in this for this problem, then we need to compute this quotient f of 3, which is the endpoint, minus f at 1, and then divide that. So that's delta f. So that's delta f, the total change in f over the interval. And then the change in x, well, you're going from 1 to 3, so you subtract 1 from 3, and this gives us f of 3 minus f of 1 divided by 2, because that's the difference between 3 and 1. Now, okay, so we need to know what's f of 3 and what's f of 1. So f of 3 is equal to, and we just need to plug 3 in the formula for f. This should be reminiscent of what we're doing when we're computing the derivative by definition, because in fact that's exactly what we're doing. We're just computing a quotient and then computing. The only difference here is that we're computing a quotient on a fixed interval, but while in the case of the derivative, we're taking a limit. But f of 3 amounts to computing 3 cubed because of this term here. So we need to plug in, wherever it says x, we plug what's inside of f, which is 3, minus 2 times x, which is up here, and that's 2 times 3, and then plus 4. 4 is here. I apologize. Okay, so that's f of 3, and 3 cubed is just 27 minus 6 plus 4. And f of 1 is just 1 cubed minus 2 times 1 plus 4. So 1 minus 2 plus 4. I'm not computing everything here because in fact we can do some cancellations. With the 4's, for instance, they always go away, the constants always go away. And so we can write this then f of 3, which is just 27 minus 6 plus 4, and then all of that minus 1. 1 minus 2 is negative 1, so minus 1, and then we're adding 4. That's f of 1, and we divide that by 2. So that's going to give us 21. 21 plus 4 minus, and now we open the parenthesis, so this minus here becomes a plus 1, and then minus 4 is just a minus 4. We can cancel the 4's, divide everything by 2. This is 21 plus 1, which is 22, divided by 2, and this is equal to 11. So that's the final answer. So that's the average rate of change. And this is the kind of thing that you'll be asked to compute, nothing more complicated than this. It's a quadratic function, square root or something like that. Okay, so that's the first kind of thing that you may see in the exam. Another kind of thing that you may encounter, it has to do with the first part of the material, will be to find limits algebraically. Find limits, so find the following limits. The following limits. And these first limits are all about performing some algebraic cancellations. So first kind of problem, say problem A. A simple one. Let me just start with a simple one. Is what is the limit when x approaches 3 of, say, the square root of x plus 1 minus 2 divided by x minus 3. Okay, this is a typical example of the problems we saw at the beginning of the semester, where we needed to manipulate the expression in order to get something we could evaluate. I mean, something that was equivalent to a continuous function. So we observe here that if you plug in 3, you get the square root of 3 plus 1, which is 4, so that's the square root of 4, which is 2. And 2 minus 2 would be equal to 0. And for the denominator, 3 minus 3 will also be equal to 0. So we'll get 0 over 0. 0 over 0 is not 1, it's not 0. I mean, it's something we've gone over many times throughout the course. So don't try to do that again. I mean, if you end up with something like that, there's something you're doing that is not right, for sure. So here we need to get rid of this this problem, and we do so by manipulating this expression. Okay, and the typical thing we did, of course there are other ways, but this is simpler in this particular problem. For this particular problem, we simply multiply and divide by the conjugate. So the square root of x plus 1 plus 2, and we divide by the square root of x plus 1 plus 2. We're just multiplying 1. And remember here that always when we're computing a limit, we're never allowing our variable x be equal to the limit. I mean the limit value. So we can cancel things out if needed, because we're not letting x take on a certain value, that particular value. So quantities like x minus 3 are never really 0. So if we multiply the top, so this by that, we get, well, you know that we're following the same thing as always, so we get just what's inside minus 4. This is just simply due to the well-known formula that x squared minus y squared is just x minus y times x plus y. And this is the idea behind, you know, the multiplying by the conjugate. So when we multiply these two expressions, we get rid of the square. We're erasing everything to square, so the square root of something squared. X is approaching 3, so that expression is positive. So we get that. At the bottom, we still have the x minus 3 and times now the square root of x plus 1 plus 2. This becomes minus 3. So we get the same thing for the numerator, and the denominator we have an x minus 3 as well. So the same thing we have as a factor here in the denominator. So we get, this is the x minus 3 times the square root of x plus 1 plus 2. And again, this is what we just said. X minus 3 is not equal to 0 because we're not allowing x to become 3. So we can cancel these two factors out, and we get the limit when x approaches 3 of 1 over the square root of x plus 1 plus 2. Now this is a continuous function, so we can just substitute the value of 3 inside, and this would just be equal to 1 over the square root of 3 plus 1 plus 2. 3 plus 1 is 4, the square root of 4 is 2, and so you just get 1 over 2 plus 2, which is then 4. And so that's our answer. Okay, so that's one kind of limit that we can be asked to compute. Now, based on our question A, what is the limit of, say, the cosine of this expression here, of the square root of x plus 1 minus 2 divided by x minus 3? when x approaches 3, what is that limit equal to? Well, that we have to remember here that cosine is continuous. So when this is the case, we simply bring the limit inside. And since what's inside is 1/4, this is what we just computed, we can say that this is the cosine of 1/4. So this was calculated above, and we simply get this. For C, we may be asked to use the same principle, so compute the limit as x approaches 2 of e to the x squared minus 4 divided by x minus 2. And question mark. So what is this? Again, e to the x is continuous. So we can use the substitution rule and say that this limit continues, so that the limit of when x approaches 2 of e to the x squared minus 4 over x minus 2, all of that in the exponent, is going to be equal to e to this limit. We can bring the limit inside because e is continuous, x minus 2. So we need to compute this limit. So we need to find this limit first. So what is this limit? The limit as x approaches 2 of x squared minus 4 divided by x minus 2. Here we can simply factor the numerator. We can write it as x minus 2 times x plus 2, and we're dividing by x minus 2. Remember that x minus 2 is not equal to 0 because we are not letting x become equal to 2. So this can be cancelled out. We simply get the limit of x plus 2 when x approaches 2. That's well defined. It's a polynomial. It's continuous, so we can just substitute the value 2 to get 2 plus 2, which is 4. Okay, so this is actually only a partial result because we're asked to compute this limit, the limit of e to x squared minus 4 over x minus 2. We saw that because e was continuous, then that's the same as e to the limit of x squared minus 4 divided by x minus 2. And so we can then conclude that this limit when x approaches 2 of e to the x squared minus 4 divided by x minus 2 is equal to, and remember we had this intermediate step, this is equal to e to the limit, and that limit is equal to 4. This is what we just computed up here. So what's in the exponent is just 4, is that limit, and that limit happens to be equal to 4. So that's our final answer for this problem. See, okay, so two comments about this kind of problems. You will be certainly asked to find the average rate of change. At least there will be one problem in the exam where you have to find the average rate of change of a given function. There will also be some computation of the limits, like problem A, um, problem C. I mean this part, like where you have to factor x squared minus 4 into, and write it as x minus 2 times x plus 2. And so that will also be in the exam. So you want problem about that? I mean, computing limits involving radicals, and so that you have to multiply with the conjugate or do something similar in order to get rid of the in getting avoiding having to plug in something that will not make sense. And so that's another kind of problem. So this one over here, like problem A, will surely be in the exam. Then another thing is this kind of applications, like when you're asked to find the limit of continuous function like cosine or e to the something. And this is an application of continuity where you can just bring inside the limit inside the function, like we did in here. So this limit of e to the something became e to the limit. And then we can find this limit inside the exponential by performing the same kind of operations that we did for a, and that's basically it. But you'll be asked to do these kinds of things. So all this will be present in the exam. We'll move on then to the next material in the next video.